Warm welcome students. Today we are going to discuss about the electrochemical cell. In 8th standard you have studied about electrochemical cells. So the electrochemical cells are the devices that is used to convert the chemical energy to electrical energy. So electrochemical cells are the devices that is used to convert chemical energy to electrical energy. There are different varieties of electrochemical cells are there, like dry cell, mercury cell, lithium ion cell, nickel cadmium cell. These type of cells are you have studied in your 8th standard. Today we are going to familiarize a new type of electrochemical cell. They are known as galvanic cell, or otherwise they are known as voltaic cell. Galvanic cell, or otherwise they are known as voltaic cell. So this will be related with the reactivity of metals. We have studied about electrochemical series and displacement reaction, oxidation and reduction, etc. By using that we are going to discuss about electrochemical cell. Okay, electricity is produced by a chemical reaction. So galvanic cells are type of electrochemical cells. So for the formation of a galvanic cell, what are the things needed for the formation of a galvanic cell? So that require two metals and two solutions of corresponding metal. So metal, two metals, then two solutions of corresponding metal. That metal should be different in their reactivity. That will be different in their reactivity. That means these two metals are not in same. Okay, you want to take two different metals and the corresponding solution of that metallic salts. Then one salt bridge and connecting wire and a voltmeter. These are the things used to make a galvanic cell. So students, please listen. What are the things we want to do here? So this explains that if you take a beaker and that beaker contains zinc sulfate solution, ZnSO4 solution, and second beaker, that beaker contains copper sulfate solution. A beaker contains CuSO4 solution, copper sulfate solution. And if you take zinc sulfate solution, you want to dip a zinc rod in this beaker, zinc rod. And if it is copper sulfate solution, you want to dip copper rod, Cu rod. So a metal is dipped in its own salt solution. A metal is dipped in its own salt solution. And the two metals are, or the metallic rods are connected by using a conducting wire with a voltmeter. Okay, that is connected to a voltmeter. Then the two solutions are connected by using salt bridge. So this is salt bridge. So what is salt bridge? A filter paper is folded. Salt bridge means a filter paper is folded and dipped in potassium chloride solution. A filter paper is taken and we are folded that and dipped in potassium chloride solution. That filter paper is known as what? Salt bridge. That is connected the two solutions. So a metal is dipped in its own solution and another metal that is dipped in its own salt solution, and the two metals are connected by using a connecting wire and connected with voltmeter, and the two solutions are connected by using salt. This is the arrangement in a galvanic cell. So what are the important things? You want to take two metals and two corresponding salt solution and a salt bridge and connecting wire and a voltmeter. If a metal is dipped in its own solution, it is known as electrode. A metal is dipped in its own solution, that is known as electrode. So here two electrodes are there. One is zinc electrode and another one is copper electrode. A metal dipped in its own solution is known as electrode. A metal is dipped in its own solution. If zinc is dipped in zinc sulfate solution, that is zinc electrode. Copper is dipped in copper sulfate solution, that is copper electrode. Then we are connected to metals by using the conducting wire and a salt bridge is there. Then what is the working of this cell? What is the working behind this cell that we are going to explain. In this case, if you are compare the reactivity of copper and zinc, if you compare the reactivity of copper and zinc, which is more reactive? If If you know the reactivity series, it is easy. Which metal is more reactive? Yes, zinc is more reactive than copper. Zinc is more reactive than copper. So the reactive metal donates the electron, and the electrons are moved towards the less reactive metal. So zinc is a reactive metal, so that will donate 2 electrons. Then how can you write the equation? It is familiar related with displacement reaction. Zinc gives zinc 2 plus 2 electron. Zinc gives zinc 2 plus 2 electrons. Zinc donated 2 electrons and become as zinc 2 plus ions. These electrons are moved towards the less reactive metal. So less reactive metal is copper. The electrons are moved towards the copper electrode through the conducting wire. So this arrow mark implies the electron flow direction. This arrow mark implies the electron flow direction. So the electron flow from the zinc to copper rod. And the solution that contain number of Cu2 plus ions and SO4 2 minus ion. These Cu2 plus ions are very nearer to the electrode. The Cu2 plus ions in the solution are very close to, number of Cu2 plus ions are there, they are very close to the electrode. So the electrons are moved towards the copper electrode. The Cu2 plus ions accept the electron that are donated by zinc. So Cu2 plus accept the 2 electrons and become as what? Cu atom. So zinc donated 2 electron and the electron moved through the conducting wire and reached the copper electrode, and Cu2 plus ions accepted the 2 electrons and become as Cu atom. So electron donating reaction. So this is oxidation, and here accepting electron, so that is reduction. Oxidation and reduction. Oxidation is the process of donating electron, reduction is the process of accepting electron. While the zinc donates, the same time copper accept the electron. So oxidation and reduction take place simultaneously. So this reaction is a redox reaction. Then how can you write the equation for redox? You just combine the oxidation and reduction. These 2 equations are combined. Left side and right side you are combining. So zinc, then here Cu2 plus 2 electron. In right side zinc 2 plus 2 electron and Cu. 2 electron and 2 electron are same in both sides. So now need to write that. So left side, how you write? Zn plus. We are combining the 2 reactions. So Zn plus. Then Cu2 plus. Then now need to write the 2 electron. So left side is completed. Gives right side Zn2 plus. There is no need to write the 2 electron because these are cancelled. And so Cu. So how you get the redox equation? Redox equation implies the oxidation and reduction take place simultaneously. That is known as redox reaction. If the redox reaction, if you want to write, just combine the oxidation and reduction equations. Left side and right side we are combining. In left side there is 2 electron, in right side also 2 electron. So no need to write the 2 electrons. The other atoms and ions here are written. So Zn plus Cu2 plus. So left side is over. Then right side gives Zn2 plus Cu. So this is the redox equation. So students, oxidation, reduction and redox. So the electrons are moving from the zinc electrode to the copper electrode. Then what is the function of the salt bridge? The function of the salt bridge is that connecting the 2 solution and completes the circuit. By connecting the 2 solution, that completes the circuit. That is a function of what? That is a function of salt bridge. Then we are now going to discuss a new concept related with this one, that is anode and cathode. Anode and cathode. Anode and cathode. What is anode? Anode is the electrode in which oxidation takes place. The oxidation occurring electrode is known as anode, and the cathode is the electrode in which reduction takes place. The electrode in which reduction takes place, that is known as cathode. So anode means oxidation occurring electrode. Cathode, reduction occurring electrode. In which electrode the oxidation occur? The oxidation occur in zinc. So here the anode is zinc, and reduction occurring copper. So the cathode is copper. So zinc is the anode and copper is the cathode. So anode is the electrode in which oxidation occurs, and cathode is the electrode in which reduction occurs. Then you want to know which is the anode and cathode very easily. That is very easy. How can you find the anode and cathode? In a cell, especially in a galvanic cell, which metal is reactive, more reactive, that is always anode. And the less reactive metal is the cathode. So here in this case, zinc and copper, you are considering zinc and copper, which is reactive, zinc, that's why zinc is the anode, and if it is copper is there, so copper is the cathode. Another one, if you are considering Fe and magnesium as electrodes. Another case, second case, if Fe and Mgs are the electrodes, you want to find the anode and cathode. Students, please listen, which is more reactive? Yes, magnesium is more reactive, so this one is the anode. And iron is less reactive than that of magnesium, so iron is the cathode. By using iron and magnesium, if you make a cell, magnesium is the anode and the iron is the cathode, so that is easier, anode and cathode. So electrons are moved always from the anode to cathode. So electrons are moving from the anode to cathode. Electron moves from the anode to cathode. So copper is the cathode and zinc is the anode. And in physics you have studied that current always move from the positive terminal to negative terminal, or positive electrode to negative electrode. Current always travel from positive to negative. But electrons, that is important, the electrons are always travel from the negative electrode to positive electrode, negative to positive. So zinc electrode is the negative electrode and copper is the positive electrode. Electrons are always travel from negative to positive. Okay, that's why zinc is the negative, anode is the negative electrode and cathode is the positive electrode. So in exams they will ask which is the anode, which is the cathode, what is the function of salt bridge, which one is the positive electrode and which one is the negative electrode. Write the equation in anode, write the equation in cathode and write the redox equation. These are the important questions. So remember that we are help you by using a code, that is ln. So while you are write ln, you just remove or erase L, then just read it. O, oxidation, anode, negative electrode. Oxidation occurring electrodes are known as anode, and anode is the negative electrode. Oxidation, anode, negative electrode. That is only applicable in the case of galvanic cells, these type of cells. Oxidation, anode, negative electrode. It will be changed in electrolytic cells, so that is important. All of you listen, it is applicable in the case of galvanic cell, oxidation, anode, negative electrode. So oxidation occurring electrode is the anode and anode is the negative electrode in galvanic cell. So what is galvanic cell? Galvanic cells are the devices that is used to convert chemical energy to electrical energy by redox reaction. So galvanic cells are the devices or arrangement in which the chemical energy is converted to electrical energy by redox reaction. With the help of redox reaction, chemical energy is converted to electrical energy. Such type of arrangement or instruments generally known as galvanic cell, or otherwise they are known as voltaic cell. So the electrons are moved from anode to cathode or negative to positive electrode. So here from zinc to copper, and the reaction, oxidation reaction, reduction reaction and redox reaction. Oxidation reaction or otherwise it is reaction in anode, and reduction reaction, reaction in cathode. What is anode and cathode? Oxidation occurring electrode is known as anode and reduction occurring electrode is known as cathode. Okay, this is an easy thing to study related with the metals. Then we are going to discuss one more example. Without a picture, we are going to explain that. If you want to make a cell by using magnesium and Fe. Already we have discussed again, magnesium and Fe are the electrodes. Which salt solution we want to take to dip the metal? If you want to take magnesium, that is dipped in MgSO4 solution, magnesium sulfate solution. Then Fe dipped in FeSO4 solution. Okay. Then they are connected by using salt bridge. The solutions are connected by using salt bridge, and the two metals are connected by using a connecting wire. Then which is the anode and cathode? Which metal is more reactive? That is the anode. So in this case, magnesium is the anode and iron is the cathode. Then electron move from magnesium to Fe. Magnesium to Fe. Students, this is your homework. Draw the picture implying the formation of galvanic cell using magnesium and Fe, and you want to write the equation of oxidation. Okay, this is your homework question. Write the equation related with, you want to draw the clear picture by using, not like this, you want to draw the picture and label the magnesium and Fe and the corresponding solution, salt bridge, etc. Your question, equation of oxidation, then equation of reduction, then redox equation, all of you want to write the redox equation, and function of salt bridge, function of salt bridge, function of salt bridge, and find the positive and negative electrodes, find the positive and negative electrodes. So your question, write the equation of oxidation, write the equation of reduction, write the equation of redox reaction, write the function of salt bridge, and find the positive and negative electrodes. These are the questions related with this homework. All of you want to write in your notebook and write the equations very clearly. You want to study the equation related with the zinc and copper. Later you just come to the section related with the magnesium and Fe. And also some questions are given in your textbook related with a table. All of you want to complete that question also related with the galvanic cells. So galvanic cells are, or otherwise known as what? Voltaic cells. Thank you.